This is the dark Doodad Nebula imaged from the southern hemisphere from the Kagakama Remote Observatory in South Africa, and today you and I are going to process this in PixInsight. I'm going to provide the data for free to anyone who would like to download it and follow along. The free link will be on Buy Me a Coffee, so there are a couple extra steps, and if you are a patron on Patreon, look for the associated post with the attachment. But also feel free to use your own data, any kind of dark nebula you have. What I show you today will be usable in any of those images. And this target here is kind of interesting. There's this globular cluster here, NGC 4372, and it's mixed with the dust in the nebula here. And it's really hard to process, but on my website, I have something that I'm kind of happy with, but it was really difficult to process. And one of the reasons I want to share this with you is to see if anyone would like to process this themselves and come up with a better solution to the glob than I have in any of my edits. And if you do use this data and you share it online, credit is always appreciated. And also hop on the Discord server, the invite link is in the description, and share your images, and I'll pick some of the best ones and share it in a YouTube post in the near future. And my goal for this video is to show you the simplest steps you can take to make the dust here really pop, because when we look at the raw image, it doesn't really look like much, but once we're done with it, it's going to pop quite a bit, and we're going to take the shortest possible path to our destination. And since we are using PixInsight, I will also provide the PixInsight process workflows in the download files as well. So let's jump into this. All right, we have PixInsight open and my stacked image of the dark Doodad Nebula. I'm just going to do a quick STF to see what that looks like. Looks fine. One thing to know is that if you do use serial to stack and it plate solves, it'll output something that looks a little bit, it looks mirrored. And the way to fix this is to go to image, geometry, and then do a horizontal mirror. And then just do a mirror until it looks right. And this is the correct orientation, just how it comes out of serial. But you saw that it got rid of the astrometric data so that it's no longer plate solved. So we do need to do that. But before we do that, I want to do a dynamic crop and make sure that the edge artifacts there don't exist. Let's do a little bit of an aggressive crop here. Close that up. And now I'm going to do a plate solve. So you can do script astrometry image solver there, or double click on the icon and then click on the global execution and then click on OK. I'm using all default settings. All right, that plate solved, so we can close this. And the next step is to do SPCC for color calibration so that our stars look good. So I'm going to do SPCC. You can also go to processes, all processes, and spectrophotometric color calibration. There's also the color calibration option here with spectrophotometric color calibration. One thing to know about this data set is that I am not using a UV IR cut filter. This was done with just the clear glass. So I'm just going to do Sony Color Sensor R, G, and B. You don't have to generate graphs, but I'll generate it anyway. And then you click on the little triangle and drag and drop. Right, that color calibrated. And next thing I'll do is I'll just restretch it so that we can see what it looks like. Normally at this point, you'd want to do some kind of background extraction, such as dynamic background extraction, to get rid of some of the gradients. But since this was taken from a Bortle 1 site at the Kagakama Remote Observatory, there is no real gradient. And if I do dynamic background extraction, I end up losing some of the faint nebulosity that you see here. But if your data has gradient, you might want to do background extraction. I normally recommend doing an edge background extraction. So you'll see that I placed these points here only at the edges, and I try to avoid nebulosity when I can. So I'm going to leave the icon here, but I'm not going to use it in this video. Feel free to use it in your data. Feel free to experiment with this data as well. The next thing I want to do is do a quick blur X, because I want to tighten up the stars a little bit before we do a stretch and extract them. I'm going to do a little bit out of order here. So I'm going to do blur X, only correct here, correct only, click and drag. And the reason we're doing this is because we don't want to really sharpen anything except just tighten up the stars just a little bit. All right, that worked. And I did forget to mention that once you select correct only, everything else grays out, so those don't really matter. Okay. And if we zoom in, if I go back and forth, you'll see that the stars just tighten up just a tiny bit, just enough. The next thing we're going to do is we're going to do a little bit of a stretch, and we're going to use MAS, Multi-Scale Adaptive Stretch. You can also use GHS if you want, but I'm just going to do a little bit of a stretch before I do a star X. And before we even turn on MAS, I want to create a small preview. So it's this button here. You can also do Alt-N. And I'm going to find a dark area in the image and then just do like a small preview here because we want to give a background sample to MAS to reference. So when double click on MAS, you can also go to Processes, All Processes, Multi-Scale Adaptive Stretch. And it is also available under Processes, Intensity Transformations, Multi-Scale Adaptive Stretch. Before we do anything, I want to make sure I click on my image here and then reset it so that it's black. Otherwise, when you do a preview, it's just going to be completely white. So we're going to click on the little circle button to do a preview. I'm going to click on the background reference and click from preview and select my one and only preview here. You can see that it changed a little bit. So I'm going to increase the target background a little bit so that don't clip any of the blacks. You can play with the aggressiveness here and the dynamic range compression. And then for the contrast recovery, you click on preview large scale component, and then we can see what we see. If you go to 1024, everything is basically just melds in. We don't want that. So I'm going to do, I think, 256. And then we can see what the difference is before and after, right? So if you do 1024, you can see the core get dimmer. And I might actually do like a pretty aggressive stretch here. Okay. And the color saturation, you don't have to do. I'm actually going to turn this down quite a bit so that I can color saturate later myself, but I'm still going to do a little bit. Okay. Now I'm going to click on the little square button to apply it. There we go. It is now applied. So this is our initial stretch. The dark Doodad Nebula is starting to pop out. The cluster still looks good. It's really hard to maintain once we start really stretching it. But we're going to do a quick star removal here. So star X. I'm going to generate a star image, leave everything else default, and then click and drag. All right, so this is our stars. Looks okay. We'll hide this away for now. You can see what I mean with the glob being so terrible. It looks like StarX did miss some other stuff here as well, some of the brighter stars. It's okay, we'll just stretch those out. And in order for me to not affect this so much, I'm going to create a range mask around this area and mask it so that when I stretch it, I'm not overstretching this. So I'm going to click on range selection. You can also go to processes and it'll be under all processes range selection. It's also under mask generation here. So range selection here. Click on preview. And I'm just going to bring up the lower limit so that until we can only see this area here. Increase the fuzziness. And then the smoothness. There we go. Okay, and then click this, and then, right. So we got our mask here, and it did mask some other stuff here. So I'm actually going to do Control I to invert it. You can also go to Image and then invert here, but Control I works. And then I'm going to move the mask under here so that it protects the little bright area here. It does protect some of the other areas as well, but since we did smooth it out a little bit, it won't be as bad. This range selection also selects some of the bright stars that Star X missed, which is nice. And then now we can start stretching it a little bit more. So we can go to Generalized Hyperbolic Stretch to stretch the rest of it. Click on Preview. I'm going to go to Linear to reset the black point. Don't clip. Click OK. Reset. Then under Generalized Hyperbolic Stretch, click on a dark area. For me, it's right around there. Click Send to SP. And then let's stretch it out. You want to be cognizant of the mask here. You don't want it to start looking weird. Okay, press OK. Okay. And then again, we're going to do SV. In hindsight, I probably could have made the range selection mask a little bit better, maybe a little bit bigger, a little bit smoother, but all good. So what I can do is I can just do a small stretch here, and then I'll close this out, and then I'll actually remove the mask, and then go back to GHS, and then do this unmasked. And it still should look okay. Click on a blank area, click on Send to SP. How much you want to stretch it is totally up to you, because we'll do some more on this in a minute. But I think this looks okay for now. Great. I'm just going to open up GHS. So you can see that the green is kind of overwhelming, because there is a green hue here. We'll take care of that soon. And then next, you can do an optional curves adjustment here. So under RGB, if you click on here, you'll see exactly where the bright area is. So, you can isolate that. You can make the background a little bit darker here. Again, be cognizant that you don't clip the data. Click OK. Okay, I think this looks fine. Just a quick curves for some extra contrast. And then now we're going to do selective color correction. This is a script. You can double click here and then click on the global context, or go to scripts, utilities, toolbox, and it's a selective color correction here. Does the same thing. So I'm going to click on this. One cool thing about all this dust is that it's mostly in the yellow. So we click on yellow in the mask, click show mask, you can see exactly what's highlighted. And we can make it brighter just by bumping up the luminance. You can see that this also gets affected, but it's all right. All right, so bumped up the saturation and contrast a little bit. You can see the before and after. Click apply. And then we can switch over to the low saturation, see what that looks like. You can see there's like most of this. Under the highlights, when you do show mask, you can decrease it so that it affects that bright area a little bit less. And you can also decrease the smoothness so that it takes a little bit of a harder stance. And then we can do a little bit of luminance again. Not much. We're just trying to brighten it up. Okay, clicked on apply. And then I'm going to click on this reset button. And you see that there's actually like a little bit of green tint everywhere. What you can do here is, you can reset the highlights, and then if you just increase the magenta a little bit, because that's the opposite of green, see that it kind of blends in now. You don't want to do too much, because then it'll start looking magenta. But I think this is good. So you can do it before and after. You can see that the green tint kind of just goes away. Click on apply, and then click on this little X to close it. Now we have a lot of noise. We can try and clean up using the noise X here. It's pretty aggressive with both color separation and frequency separation. Click and drag. All right, so we can close this. We can zoom in and see what the noise looks like before and after. Right, kind of magical. The glob area here, always like, oh man, what can I do to make it look better? Maybe some of you can help with that. Right, before we do a star stretch and start pulling everything in, one thing I didn't include here is, because it's totally optional, is if you go to script, go to utilities, there is a script called dark structure enhance. It's one of the scripts that you can use, and we can try and enhance some of the dark nebulosity here, see what that looks like. I want to decrease the layers to 7. I don't want to do too much, so I'm going to do like 0.3, and then click OK. All right, that did it. So we can go before and after. You can see that it just like increased the contrast a little bit. And I think that looks fine, right? You can definitely play with that script, see what you get. And you'll notice that I didn't actually use any kind of blur X except for correcting some of the stars. The next thing to do is play with our stars a little bit. So I have the star stretch script here, but since we already pre-stretched this, I'm just going to use curves and stretch it a little bit more that way. You can also use GHS, but I'm just going to do it this way. Click on start, and then increase the saturation a tiny bit. It is looking very red, so what we can do is go to R and just turn it down just a little bit. and you'll still see, some red, blue, yellow stars. Starts to look pretty good. And if you want to do any more stretch, you can open up GHS and pull it out. And it'll look something like this. There's a little bit of green here. We can take care of that with SCNR. And then I'll keep it here. I'll just show you what SCNR is doing. It's just trimming it down a little bit. Yeah, so you can see that, like all these green areas here now looks blue because, that's the better color. And you can see that from GHS, the green just turned down a little bit and it kind of color corrected the rest of them. So SCNR at the very end is, don't close it, is good. Next thing we want to do is we want to do image blend. So in version 1.9.3, it used to work in global context, but it doesn't anymore. But I still leave it here for a reminder for you to go to script, utilities, and image blend. Right? And when that opens up for the view, we're going to click on image 1 or whatever you called yours. And then for the blended image, it's going to be image 1 stars. It'll see that it starts to hide a lot of the defects that we see. And it starts to look kind of cool, right? So if you want to trim down some of the stars, you can increase the black point just a tiny bit. You can also make the background a little bit better on the nebula itself. Don't do more than like 5%. You can click and drag, create a little box here, and it'll zoom in. We can see what the star cluster looks like. Doesn't look the best in my opinion, but didn't spend as much time on this as I normally would. But even then, anyways, double click on that to get out of it. But this is starting to look pretty good. Alrighty, I think this is pretty good. Alrighty, comparing this to what I have posted before, you can see that on my website it's a little bit more yellow. It has a little bit more color on the nebulosity side. This one is a little bit gray. This is, again, has to do with how you process it and what it looks like. I did spend a little bit more time on the star cluster here than I did on this here, but hopefully I gave you the tools in order to really go in and play with the settings and see what you can get out of this. I hope that was helpful, and I'm planning on making more data available from remote observatories whenever I can. And as some of you know, I am sending one of my rigs down to Death Valley Observatory soon, so I'll have some crispy data from the Northern Hemisphere as well. I'll provide as much data as possible to paid supporters as I can, and I'll also eventually make a lot of those available for free to everyone to use and follow along as well. And with that said, a huge thanks to all of my patrons on Patreon, supporters on Buy Me a Coffee, and here on YouTube. You've given me the confidence to have multiple rigs around the world and to do these videos, so huge thank you. And as always, thank you for watching, and until next time, clear skies.